All right, so a couple things we need to define. Oh, William just turned his campus stuff in. All right, some definitions. All right, yeah, I don't know if I'm going to be a fan of this. All right, what is anything divided by 0? Say that again. Undefined? Okay, and I'm going to argue no. Okay, we're not going to say it's undefined. Okay, it is a type of infinity. Anything divided by 0 is a type of infinity. So, what does that depend on? What kind of infinity will it depend on? All right, well, anything divided by 0 is going to be positive infinity if what's true? If k is positive. So if k is greater than 0. So anything divided by 0, when would it produce negative infinity? All right, if k is less than 0. When you divide by 0, it's going to produce a specific form of infinity. So I need you to kind of get in the habit of thinking of that. Yes? Okay, that is a whole nother ball game, which is a BC calculus topic, but we can talk about that in a minute. Let me pause. So notice, Cassidy, I did not put equal to. Okay, k is never equal to 0. Okay, so it's got to be either greater or less than 0. Okay, well, what if you have k divided by infinity? What's that? Okay, what kind of 0? Did you know that there's more than one kind of 0? All right. If k is divided by infinity, which is a gigantic number, so if you take something and you divide it by the biggest number you can think of, you'll always get 0, but it's not ever exactly 0. It's either 0 plus, which is something a smidge greater than 0, but so small you can't really tell what it is, or k divided by infinity is 0 minus, and again, that depends on what k is. If k is greater than 0 or if k is less than 0. Oops. All right. What if you have negative k divided by 0 minus? Okay, what about negative k divided by 0 minus? Okay, well, k is clearly negative. What about 0 minus? What kind of a number is that, positive or negative? It's negative because it's just a tiny bit smaller. And so the answer to that is going to be some kind of infinity, but what kind? Okay, that is positive infinity. What about negative k divided by 0 plus? Well, now you have a negative number divided by a positive number, and it's going to be some kind of infinity. What type of infinity will that be? Okay. So basically the rule of thumb is if you divide by 0, you're going to get infinity, some kind of infinity. If you divide by infinity, you're going to get some kind of 0. Assuming that the numerator is just a constant. Okay, so let's get that rule of thumb down. Okay, divide by a form of 0. Will result in a form of infinity. Hopefully that logically makes sense to you. You're dividing by something that is so small. This is the smallest number you can think of without being 0. Division by a super small number results in a super large number. And then the converse is true. Dividing by the largest number you can think of, so divide by a form of infinity, And that will result, I don't like this pen, didn't take me long, in a form of 0. Please note, I'm not saying it's going to be equal to 0. It's going to be equal to a form of 0, which is either 0 plus or 0 minus. All right, so this is sort of super fun math. So that's our rule of thumb when we're dealing with infinity. All right, so let's try a couple, what this actually looks like when we do limit problems. All right, let's find the limit of the function x plus 3 over x minus 2. And what would be the one number you wouldn't want me to be approaching here? Yeah, you wouldn't want me to be approaching 2, because 2 is going to violate the denominator. So we're like, fine, I won't approach 2. I'm going to approach 2 plus. You can't plug in 2, but you can plug in 2 plus. It's just getting around the rule. It's finding the little loophole. You can't plug in 2, but you can plug in 2 plus. So plug in 2 plus, we're going to get, 2 plus 3 over 2 plus minus 2. What's 2 plus 3? 5 plus, okay? Something a little bit more than 5. What's 2 plus minus 2? Still positive. So I have something divided by 0, which should give me some form of infinity. And which particular form of infinity will that give me? It'll give me a positive. Okay, so anything divided by 0 is going to give me a form of infinity. Well, okay, so if you're looking at a graph, you can look at the limit from the right side. So that means that the limit on the right side of this, if you were drawing it, okay, if we had the number 2 here, there would be an asymptote at the number 2, and that this function would be coming on that side. That's what it's going to look like visually. All right, but we're doing it without our calculators, so we're not taking a look at the graph. Yeah, but that's what would happen. If you were describing what would happen, it would be on the right-hand side, this graph is heading at a vertical asymptote up to infinity. Yeah, Jerry. I'm going to want you to specify the form of infinity. Yes. Okay. All right, let's try another one. All right, so that was just a basic. All right, how about the same function, x plus 3 over x minus 2, and let's approach on the other side. So let's plug in 2 minus plus 3 over 2 minus 2. It's kind of a snarky little thing. It's like, can't plug in 2, and you're like, no, I'm not plugging in 2, I'm plugging in 2 minus. All right, well, what is 2 minus plus 3? Something tiny bit smaller than 2, and you add 3 to it. Where do you end up? 5 minus. You end up a little bit less than 5. So 4.999999999. All right, how about something less than 2, but then you subtract 2 from it? Where do you end up? You end up on the other side of 0. All right, again, I'm dividing by 0, so I'm going to have some form of infinity as my answer. What particular form of infinity will I have here? I heard positive. Why positive? Make the argument. 5 minus is not a negative number. Ooh, wait. 5 minus is not a negative number. What's 5 minus? 4.9. That's a positive number. So what kind of number's on top? A positive. What kind of number's on the bottom? So it's not 2 negatives make a positive. It's one of each. And so the answer is negative infinity. Okay, it is not 2 negatives makes a positive. Only one of those numbers is negative. The only number that's negative is the one that's the 0 minus. Okay, any other questions on that? Okay, all right. Oh, I guess we could go back and address Ian, what Ian brought up. What does that mean? Like graphically, what does that mean? Approaching 2. From the left-hand side, if you're playing chicken and you're approaching the number 2, where are you going to head when you hit that asymptote? Which direction? Down. So it's going to be coming across here, playing chicken, and then shoom, heading down towards that vertical asymptote. That's called behavior. They say, what's the behavior on the right side of the asymptote? What's the behavior on the left side of the asymptote? Okay, the right side of the asymptote is heading to positive infinity. The left side of the asymptote is heading to negative infinity. All right, let's try another one now. All right, how about the limit of the function 4 over x squared and x is approaching infinity? All right, well, the only rule is I can't plug in something that would make the denominator 0. So I won't be making the denominator 0, so I'll have 4 over infinity squared. What's infinity squared? Super infinity, yeah. Okay, like infinity squared bolded. It's a really big infinity. But what's the rule when you divide a number by infinity? You get some form of 0. Which kind of 0? Okay, we get a positive 0. So we're going to be on the positive side of 0 here. That means we're above the x-axis because 0 is along the x-axis, and we're going to be on the top half of that, on the upper half. So if you're thinking about, well, what does that look like? You know what 4 over x squared looks like. You know that 4 over x squared is an inverse square graph. And we know that out here, it's always going to be on the top side of the x-axis. It will always be 0 plus. Okay, barely positive. Okay, let's try the limit as x approaches infinity of 5 plus 1 over x. And again, the rule is you can plug something in as long as it doesn't make a denominator 0. And that's fine. This won't make a denominator 0. I'll have 5 plus 1 over infinity. We know that 1 over infinity is going to be some form of 0. So that's going to be 5 plus a form of 0. Which particular form of 0? 0 plus. So I will end up at 5 plus. That means that this graph is going to always hover, as it goes out to infinity, out to the right, it's always going to hover right above 5. That's its horizontal asymptote. So this graph is going to be out here, but it's going to always hover. If we say that 5 is right there, it will always be hovering just above 5 plus. Okay, any questions about that so far? Okay. All right, how about this one? The limit of the function 2x to the second minus x plus 3 over 3x to the second plus 5, and do that as x approaches infinity. All right, here's a mess. Remember how previously when we were doing limits, you had to do some algebraic simplification before you just went ahead and plugged it in? Because, let me tell you why. What's going to happen if you just plug infinity directly in? Well, you're going to get 2 times infinity squared minus infinity plus 3 over 3 times infinity squared plus 5. Okay, well, what's 2 times infinity squared? A strong infinity, okay, a super infinity. Minus an infinity, still a super infinity, plus 3, still an infinity. So you would end up after all of that with an infinity. What about on the, whoops, that was no good infinity. What about on the bottom? 3 times an infinity squared is a super infinity, plus 5, still a super infinity, and then we just learned that this is called an indeterminate form. All right, so this is no good. You cannot plug infinity directly in, so you got to do some algebra. The algebra is, when you are faced with that is to divide everything by the highest power of the variable. Divide everything by the highest power of the variable. So, what is the highest power of the variable in this problem? X squared. So you're going to divide everything. 2x squared, you're going to divide it by x squared. X, you're going to divide it by x squared. 3, you're going to divide it by x squared. The denominator, 3x squared, you're going to divide it by x squared. And 5, you're going to divide by x squared. Why is that legal? If I divide the top and the bottom by the same thing, it's like multiplying the top and the bottom by the same thing. I'm dividing by 1. Because I've divided the top number all by x squared, I've divided the bottom number by x squared, I've divided everything by 1, and so it's legal. I haven't changed anything. Now we're going to simplify. So we've got, in the parentheses, what's 2x squared divided by x squared? 2. And x squared divided by, or x divided by x squared is 1 over x. And then 3 over x squared. And in the denominator I get 3 plus 5 over x squared. Now try plugging in infinity to that form of the problem. And if you try plugging infinity into that form, you won't run into a problem. Because you're going to get 2 minus 1 over infinity, which is a form of 0, plus 3 over infinity squared, which is a form of 0, over 3, plus 5 over infinity squared. So everything that's over infinity is a form of 0. So we've got 2 minus a form of 0 plus a form of 0, which we'll have to decide. Those are both positive. And then the denominator is 3 plus a form of 0, which is also positive. So I'm going to get 2 over 3 positive. And so this thing has a limit where it's always going to be hovering above 2/3. Okay, if you look at a graph to confirm it, this thing will level off, but it's going to level off in such a way that its horizontal asymptote is just hovering right above 2/3. Yeah. Because the 0 plus and the 0, they canceled each other out. So we've got 1 0 plus and 1 0 minus. Right here. So this thing, we can, yeah, they negate each other. The implications here, that the horizontal asymptote is above 2/3. Okay, so we're just hovering right above that. Okay, let me see.